Okay, so we're going to look at solving quadratic inequalities algebraically. Alright, so what that means, what we're looking for like big picture, is for this quadratic, we know it's quadratic because it has an x squared as the highest exponent. So for this quadratic, which like range of values are less than or equal to 0? So graphically what that looks like, okay, is if we know we have a parabola, our a value is positive, so we know it's facing upward. So rough sketch here. Okay, so in relation to your x-axis, right, because where are your values less than or equal to 0? Well, on the quadratic, graphically, it would be anything underneath that x-axis that would be smaller than 0. So notice we will need these x-intercepts because those are going to be our point of reference. And so we need to solve for these first, and then we're going to use those points to evaluate if the function, if the y value is greater than 0, or if the y value is less than 0, and we're looking for where it is less than 0 for our answer. Alright, so we can come off to the side, and we're going to solve for x, because we need our solutions, or the x-intercepts, zeros, roots, in order, again, for our points of reference. So you can solve by quadratic formula, by completing the square, or by factoring. So we'll factor here just because it's going to be a little bit faster. You always want to check to see if it's factorable. If it's not factorable, then move to one of the other two methods. Okay, so we can do x method here. So 5 goes up top, negative 6 on the bottom. So two numbers that multiply to positive 5 that add to negative 6. Okay, so if it has to multiply to 5, our only factors of 5 are 5 and 1. Right? And so if it has to add to a negative, then you know they're both going to be negative. So negative 5 and negative 1 multiplies to 5 and then adds to negative 6. So we can put our factors underneath our quadratic in standard form. So x minus 5, x minus 1 less than or equal to 0. Okay, so then we want to still go ahead and get our solutions. So we can set them both to 0. And go ahead and solve. We can change them to equal signs here because we're looking for these exact points. So those are equal signs. We'll come back to the number line or the inequality in a second. So plus 5 plus 5. So x equals 5. X equals 1. So those would be your solutions. Okay? So now, right, difference between an equation and inequality is we have a number line. We have something to shade. So I'm going to create my number line, and I'm going to put my point. You always use 0 as a reference, so 1 here, and then like 5 here. Alright, so what you're going to do is you're going to pick test points, okay, that fall on your number line. I'm going to zoom into my number line here. Some test points that fall in these three sections, okay, so 1 and 5, when you plot your critical values, that's what they're called. When you plot your critical values, you divide this into like three sections. So section 1 is anything less than 1. Then you have section 2, which is between 1 and 5. And then you have section 3, which is anything greater than 5. Alright, so then you pick a test point in each section, and you're trying to see when you plug that value in, is that less than 0 or is it greater than 0? Okay, so think about all numbers less than 0 are negative. Anything greater than 0 is positive. So really we just kind of care about the sign of the number, not so much the actual value. That's why you can pick anything in these sections and it'll give you the same answer. Okay, because you're just looking for is the number positive or is it negative? Alright, so notice 0 is already over here. So I'm going to use 0 as my test point for section 1. Okay, so you plug in 0. You can plug it in either into this top equation or the factored form equation. It doesn't matter. 0 might be easier to plug into the standard form. When I say easier, I just mean like really quicker. Okay, so if I plug in 0 here, 0 squared is 0, minus 6 times 0 is 0, and then plus 5. So 0 plus 5 is 5. So is 5 positive or negative? It's positive. So we can represent section 1 on that part of the number line as positive. Okay, and I'll come back to that in just a second. Okay, so then we have to pick a number between 1 and 5, so I'll pick 2, but you could pick 3, you could pick 3.5, you could pick 4, it doesn't matter, 4.1. Okay, everybody could pick a different number, and you're going to get the same positive/negative result, depending on what it is. Okay, so when I plug in 2, I'm going to plug it in here to this factored form so you can see it works the same way. So 2 minus 5 is negative 3 times, and then 2 minus 1 is 1. And then negative 3 times 1 is negative 3, so that represents a negative solution for section 2. So section 1 is a positive, section 2 is negative, section 3, so we need anything bigger than 5, so I'll just plug in 10. Okay, but you could do anything bigger than 5, doesn't matter. Okay, and I'm going to do it into this factored form again. So 10 minus 5 is 5, times 10 minus 1 is 9. Even if you don't know what 5 times 9 is, which is 45, okay, even if you just realize it's a positive times a positive times a positive is going to give you a positive solution, and that's all we care about for our spots on the number line, okay? So now we're looking for which spot on this number line is a solution to the original problem. Okay, so since we're looking for what is less than 0, again, numbers that are less than 0 are negative numbers. So we are looking for which section on the number line is negative, which is section 2. So I have to write my final answer saying, hey, all the solutions that would make this true, all the negative values that are less than 0 are in section 2, and that's between, I kind of covered up my 1, that's between 1 and 5. Okay, so how you represent that as a final answer, you represent on a number line by shading. Okay, close dots because it's or equal to. And then we represent our final answer as an inequality where we say I want all the values from 1 less than or equal to x less than or equal to 5. So any x value between those points are going to create y values that are beneath the x-axis. That's basically what you're trying to communicate. Alright, let's look at another one. Okay, so on this one, first step, we have to add our 7 over. You have to add your constant over because you want it to be set to 0. So then you can evaluate based upon your x-intercepts. Okay, so just like normal, we're trying to figure out where the quadratic this time is greater than 0. So let's figure out where it is equal to 0 by factoring. So 20 up top, 9 on the bottom. Alright, so two numbers that multiply to 20 that add to 9. Hopefully you came up with 5 and 4. Okay, so then you put those in your factored form. So x plus 5, x plus 4, greater than 0. Okay, so first we have to solve for our critical values, the numbers that go on the number line. So that would be x equals negative 5, x equals negative 4, because you set these both to 0. So these are the numbers, these are your critical values. And they go on the number line. Okay, so let's create our number line. I'll leave that kind of in the window there. Okay, so negative 4. Be sure you're getting your negatives plotted correctly. And negative 5, because if not, that'll throw off your sections. Alright, so we have section 1, section 2, section 3. Okay, so a number that's less than negative 5. Well, actually, let's go ahead and do the open dot, closed dot so we don't forget for our shading. So since it's just a greater than sign, there's no or equal to. Those are open dots. So let's go ahead and put open dots on our values. Okay, so now I need a number anything less than negative 5. So I'll do like negative 10. Okay, so now I'm going to plug in negative 10. You could do it to the standard form one, actually that one right there, or you could do it to the factored form one. I think the factored form is a little bit easier to do in your head. So negative 10 plus 5, so right here is what I'm plugging into, is negative 5 times, and then negative 10 plus 4 is negative 6. Okay, again, if I don't even really care about the value, I just care about the sign of the number, a negative times a negative is a positive. So this region here is positive. Okay, then I need a number between negative 5 and negative 4. How fun. So we could do like negative 4.5. Okay, so if I plug in negative 4.5 up here to this factored form, so negative 4.5 plus 5 is 0.5. And then negative 4.5 plus 4 is negative 0.5. Well, here we have a positive times a negative, which is a negative. All right, and then my last one over here, I need something bigger than negative 4. I always like to use 0 anytime I can, depending on which section it's in, so it would be over here in this last section. Because I can plug in 0, I like plugging in 0 to this one right here. This standard form one, because it goes 0, 0, and then you're just left with your constant, right? It's like solving for your y-intercept. So it's just 20, and 20 is a positive number, so that region represents positive. Okay? So then we go to our original problem and we say, hey, we are looking for all the values greater than 0. Well, all the values greater than 0 are positive numbers. So we're looking for where it's positive on the number line, and we can shade that way. So I cover up my positive with shading, cover up positive with shading. Make sure you don't cover up your open dot so we can see that. That's how you represent it on a number line. And then to represent as an inequality, we're trying to say, hey, I want any of the x's smaller than negative 5. So x is less than negative 5. All right? Or any x value greater than negative 4. And that's how you can represent your answer as an inequality. And you need both. You need the inequality and the number line.